Dear friends, welcome to today's video on Introduction to Artificial Intelligence, and it is part 3. So in my previous video, we have discussed the block which represented the artificial intelligence definition and also the different categories which are associated with the various definitions given by different scientists in this field. Okay, now today we will be talking about each of these blocks in detail. Now if we can recollect, we call a system to be an AI based system if that particular system can think like human, act like human, think rationally and act rationally. Okay, so first of all, let us begin with the second block, which says acting humanly or systems which act like human. For this, we generally make use of a very simple approach which is known as the Turing test approach. The Turing test, it was proposed by Alan Turing in the year 1950, and it was designed to provide a satisfactory operational definition of intelligence. So rather than proposing a long and perhaps controversial list of qualifications which are required for intelligence, he suggested a test based on indistinguishability from undeniably intelligent entities which are known as human beings. Okay, so in this game or in this test, there is a human interrogator, a human player, as well as computer player. Now we are testing whether this computer is equipped with AI or not. The computer will pass the test if a human interrogator, after posing some written questions, cannot tell whether the written responses come from a person or not. That means interrogator will be posing a written question. Let's say, what is the capital of Assam? So if this particular written question is posted to both the human as well as the computer, and from the computer player the interrogator receives the answer as Dispur, as well as from the human the response is also Dispur. So the interrogator will get confused, right, that which answer is given by whom. So hence, if this situation arises that the interrogator is not able to say whether the answer has been given by a human or a computer, at that point of time we can say that the computer has passed the Turing test. Okay, so this is a very simple test and a very basic approach in finding out whether a particular system is intelligent or not. So in order to perform the Turing test, the computer should have natural language processing, knowledge representation, automated reasoning, and machine learning. Now natural language processing is in order to enable the computer to communicate successfully in a particular language. It might be English, to be very generic. Okay, then it should also be equipped with knowledge representation, which is to store what it knows or hears. So it will behave like a database where it will store the various things which the computer system will know, hear, or being fed with, being given information of. Then it should also be equipped with automated reasoning, and this by the property of this, the computer will make use of the stored information to answer the questions and will draw new conclusions. Okay, so new results would be generated using this automated reasoning. Okay, and the fourth important parameter that the computer should be equipped with is to adapt to new circumstances and to detect and extrapolate the patterns. So we have to understand that we need to adapt to new circumstances, right? So if the computer is also being able to adapt to new circumstances or learn from different patterns which are happening, that means it is it that means it should be equipped with this machine learning concept. Okay, so let's say, let me write it down for you. It is able to learn from patterns, or identify patterns. So if this is incorporated, only then a computer can be subjected to the Turing test approach. Otherwise, without any of these parameters, the experiment will not be a successful one. Now, this Turing's test deliberately avoided direct physical interaction between the interrogator and the computer because the physical simulation of a person is not necessary for intelligence, right? However, some scientists argue that no, physical simulation is also necessary. Okay, hence they propose the introduction of a video signal so that the interrogator can test the subject's perceptual abilities, whether the subject can see things or can perceive various videos, and from there it can derive any information. Okay, also they wanted the interrogator to pass physical objects through the hatch, and in order to incorporate this video signals as well as passing of objects, they had to incorporate two different other factors, which is the vision and the motor control. So vision, in order to establish this vision, they made use of different types of sensors. Okay, they made use of various types of sensors, cameras, etc., to be incorporated with the system that is under Turing test, as well as motor control, so that they could pass certain things to act upon the objects if it is requested. So the classical example of this can be a robot. So a robot can take things, pass things, as well as act upon different things if it is required. So vision and motor control were two other parameters which were combined with Turing test in order to perform a total Turing test. So right now, if any approach related to acting humanly concept needs to be developed, it has to pass the total Turing test. Okay, the next we will talk about the thinking humanly concept, which is also known as cognitive modeling approach. Now, if we are going to say that a given program or a given computer system thinks like a human, we must have some way of determining how humans think, right? So in order to answer this, we need to get inside the actual workings of the human minds. Scientists, after a lot of research, they found out that there are two ways to do this. One is through introspection, which is trying to catch our own thoughts as they go by. Okay, this is from the life experiences or life thought process. Okay, whatever is going in our mind, so through that particular mechanism. And the other one is through psychological experiments. That means we have certain established psychological experiments and we will be doing them so that it is we can prove whatever is going in our minds, right? So this is how the human minds think. So once we have sufficiently precise theory of the mind, it becomes possible to express the theory as a computer program. And if the program's input and output and timing behaviors match the corresponding human behaviors, that is evidence that some of the program's mechanism could also be operating in the humans. So if somehow we can incorporate these two parameters through anything into a particular device, okay, through a computer program in a particular computer system, then we can say that we have imitated the human thought process inside that computer and we are making it as intelligent. So this gave rise to a new interdisciplinary field which is known as cognitive science, and it brings together computer models from AI and experimental techniques from psychology. So this cognitive science is a very, very interesting branch, as it it tries to construct precise and testable theories of the workings of the human mind. So if we are considering cognitive science, it is actually how it describes how basically humans think, right? So this is a very very interesting concept, and we should always be alert while we are doing AI, because we need to be sure of whether we can incorporate our own thought process into that particular machine or not, with the help of various established models and experimental techniques. Okay, so in the early days of AI, there was often a confusion between the approaches. An author would argue that the algorithm performs well on a task, and that is therefore a very very good model of human performance, or the reverse, or vice versa. Okay. However, modern authors do not believe it. They believe that there are two separate kinds of claims, and this distinction has allowed both AI and cognitive science to develop more rapidly. Okay. The third block that we will be discussing is thinking rationally, or the laws of thought approach. So up till now we have been discussing about the human performance centric approach. Okay, how humans think and how humans act. Okay, so for acting like a human, it should go for we should go for a Turing test approach, and for thinking like a human, we can use our own introspection as well as psychological experiments. However, from this point onwards, we will be talking about the rationalist approach, or the um, sector, or of that or section of that particular those particular sections of the definition which involves computations and engineering as well as mathematics. Okay, so the Greek philosopher Aristotle was the first one to codify the right thinking, that is irrefutable reasoning processes. Okay, so this was the first man. Aristotle was the first man, and he basically coined this particular term of right thinking, and his syllogisms also provide patterns for argument structures that always yielded correct conclusions when given correct premises. Let me give you an example. Suppose there is a premise 1 which states that Socrates is a man, and there is another premise which states that all men are mortal. Now, if we are thinking in the right order and making use of these two premises which are already there, we can infer from these two particular sentence, or these two particular premise, that Socrates is also mortal. Okay, because Socrates is man, and all men are mortal, so definitely Socrates is also mortal. So how did we actually deduce this? With the laws of thought approach, because we thought in a rational way supported by the evidence of these premises. Okay, and we came up to a correct conclusion, right? And it is also based on facts and deductions which are based on this fact. So these two are the facts that I was talking about, and this is the deduction which we got. Now, there are two main obstacles to this approach. So the first one is that it is not easy to take informal knowledge and state it in formal terms, which is required by logical notation, particularly when the knowledge is less than 100% certain. Suppose we do not know that whether Socrates is a man or whether all men are mortal. So we do not know about any of this, either this or this. We do not have the correct information or 100% information. Then it might be so that we might not arrive at the correct information or correct inference. And second one is that there is a big difference between being able to solve a problem in principle and doing so in practice. For this, I would like to illustrate an example which states that, if illustrated an example which is basically related to the launching of a rocket from the terrace of your home. So if I have asked you to design a rocket basically, which will be which we can launch it from the terrace of your house. So I think with the help of mathematical formulas as well as computational models, we would be able to design this particular rocket. However, if that is in principle, that is on pen and paper, in computer systems you can develop it, but practically, if in practice I am talking about launching this rocket from your terrace, it is not possible. Okay, so that is why there is a big difference between solving a problem and in principle and solving it in practice. So these are the two main obstacles of the thinking rationally or the laws of thought approach. Okay, and the last block that we will be discussing for today is acting rationally or the rational agent approach. So for this we need to have an agent, and this agent can be defined as something which acts, basically something which performs any action. Okay, and like the laws of thought approach in the previous slide, it also gives importance to correct inferences. Now we also have to understand that this agent is not a normal agent but a rational agent. Okay, so what is a rational agent? A rational agent is one that acts so as to achieve the best outcome or when there is uncertainty. Okay, suppose I have, as given in my discussed in my previous slides or in previous video, so suppose I have to reach from point A to B and I have several routes which would lead me from A to B. Now I have to find out the best possible route. So if I am considering the correct inferences as well as correct constraints associated with it, now I will find out that this particular route is the best possible or the most feasible route, which would be from A to B, right? So I am picking up the best possible outcome from a lot of alternatives which are there in this particular example. Okay, so rational agent will be that agent or that computer program which will be picking up the best possible route, in this case the shortest route. Okay, at all and at any type of environment. All right, so the computer agents are expected to have other attributes which would distinguish them from mere programs. So if there is a computer program, we will call it as a agent. Now if we are considering it as a rational agent, then it will be having some more attributes like operating under autonomous control. It should be able to perceive the environment, persist over a long time. Then it should be adaptable to change, and it should also be able to take on others' goals. So all those attributes. So simple a program is basically an agent. Okay, and if we are trying to convert it into a AI based agent, so we have to incorporate the program plus attributes with it, program plus attributes to it. So this AI based agent is basically your rational agent. Okay, and it will give you the best possible outcome in all possible scenario. Okay, now correct inference, we talked about that it gives importance to correct inference. Now correct inference is not all of rationality. That means it is not always rational. Okay, because there are often situations where there is no provable correct thing to do, yet something must still be done. Like if I am taking this example, recoiling from a stove. Now if I am touching a stove, I know that it is hot. Okay, so I will simply remove my hand from it. Now what should be the most rational approach? I would also be trying to remove the plug from the electric board, or maybe I should try to cool it down. Okay, so that could be one of the rational approaches. But because of our reflex which is there in our body, the best possible thing at that point of time is to just withdraw our hand from the iron. Okay, let me give you another example. Suppose a mosquito is biting in on your hand. Now what do? You will simply slap the mosquito and kill it, right? Now that is not a very rational approach. You just killed a life, right? But I mean, that is not a very good concept. You could simply have distracted the mosquito, or just have used a paper in order to remove it from your hand, right? So that could have been done. It would have been more rational without killing a life. But at that point of time, nothing came to your mind, your reflex worked, and you simply slapped on the mosquito and it died, okay, and you killed it. So it is not always that though we know about certain circumstances as the correct inferences, it might not be a very very rational thing to do at that point of time, or it might not generate rationality. Now achieving perfect rationality is also not always the right thing to do, as it may exhaust computational resources. As already said, if I'm trying to launch a rocket from the terrace of my house, I would be able, let's say I built it as well, okay, now designed it well, I have constructed it well, but what happens is I have exhausted all my financial resources, and it might cause severe damage to the house, to the terrace of my house, okay, it might not launch at all. So all those things would be associated. So hence we must also be concerned about, even though it might generate some rationality that we are trying to launch a rocket from the terrace of my house, okay, in order to go for space exploration or something like that, it sounds a very rational approach. However, we also have to keep into consideration the environmental factors as well as the computational resources which are available. So this is in a nutshell what the definition of AI actually means. So AI basically stands for developing that branch of science which is used to enable a machine to think like a human, act like a human, think rationally and act rationally. So this is all for today. We shall again discuss further on this topic, okay, in our subsequent videos. Thank you.